This question is very similar to the previous one. To evaluate the integral contour c, z squared minus 1 over z dz. And the contour c is expressed as z equals 2 times e to the power of I theta. However, this time, theta is from pi to 2 pi. So following the general steps, the first step we need to do is that we just substitute z into this equation. So it becomes integral on contour c, the equation about z squared minus 1 over z times dz. And since z can be expressed as the equation using theta, so next step we just need to make dz into d theta. And we know theta is from pi to 2 pi, so the given integral function can be rewritten as integral from pi to 2 pi z squared minus 1 over z times 2 times e to the power of I theta times I d theta. So this step we changed the dz into some equation d theta. And these two items can be cancelled, so this integral function can be rewritten as integral from pi to 2 pi I times 2 times e to the power of I theta squared minus I d theta. And then the next step is that we need to find the antiderivative of this function, which is 2 times e to the power of 2 I theta minus I theta. And then we just substitute theta with 2 pi and pi and then do the math. Here shows the equation, which is 2 times e to the power of 2I times 2 pi minus I times 2 pi. And then minus 2 times e to the power of 2I pi minus I pi. Do the simple math, which is 2 times 1 minus 2 pi I, and then minus 2 times 1 minus I pi. So the final answer is minus pi I.